morning students. In this session I will solve some 3 and 5 marks questions. See the first question. Prove that 1 divided by 1 plus x to the power p minus q plus 1 divided by 1 plus x to the power q minus p equal to 1. You need to prove right hand side equal to 1. For that reason consider LHS of the problem. LHS is 1 by 1 plus x to the power p minus q plus 1 by 1 plus x to the power q minus p. So it is equal to 1 by 1 plus, here see x to the power p minus q is there. You can write it as x to the power p by x to the power q. Okay. Reason is, since x to the power m divided by x to the power n is x to the power m minus n, plus similarly 1 by 1 plus x to the power q minus p, you can write it as x to the power q by x to the power p. Here also applying the same formula. In the next step, see, it's equal to 1 divided by, here x to the power q is the LCM, so cross multiply x to the power q plus x to the power p divided by x to the power q. X to the power q into 1 is x to the power q plus x to the power p, denominator x to the power q, plus here see 1 divided by, here LCM is x to the power p, right? So cross multiply x to the power p into 1 is x to the power p plus remaining term is x to the power q divided by x to the power p. It is equal to, see, here see x to the power q is there, right? This will move to the numerator. This term also you can take it to numerator. Okay, why? Because a by b whole term by c by d, then bc, d moves to numerator, so you can write it as ad by bc. So take x to the power q to numerator, you will get x to the power q divided by x to the power q plus x to the power p plus here x to the power p moves to numerator, x to the power p divided by x to the power p plus x to the power q. Okay. In the next step, see, suppose 1 by 2 plus 2 by 3 by 2 is there. Then how you add these two numbers? You can add it directly because they have the same denominator, right? So you can write as 4 by 2. Similarly, see, x to the power q by x to the power p plus x to the power q, a plus b can be written as b plus a, plus x to the power p by x to the power p plus x to the power q is there. Denominator is same. Denominator is same means you can add the numerator directly. So we will get x to the power p plus x to the power q divided by x to the power p by x to the power q, x to the power p plus x to the power q. Then this term get cancels. 1 by 1, its value is equal to 1. Therefore RHS value equal to 1. Hence the result is proved. See the next question. Prove that x to the power b minus c into a into x to the power c minus a into b into x to the power a minus b into c equal to 1. Okay. Here see, consider the LHS of the problem, that is x to the power b minus c to the power a into x to the power c minus a to the power b into x to the power a minus b to the power c. Okay. In the next step, see, which formula we need to use here? X to the power m to the power n is x to the power mn. So multiply the powers. So it's equal to x to the power b into a is ba minus c into a is ca into x to the power c into b is bc minus a into b is minus ab. Okay, multiplying a to b into x to the power, see, a into c is ac minus b into c is bc. Then the next step, see, x to the power m into x to the power n into x to the power p. What's the formula? X to the power m plus n plus p. Okay, here see, base is x, here also base is x, here also base is x. So you can add the powers. So you will get x to the power BA, or you can write it as AB, because 2 into 3 is 3 into 2, right? AB is equal to BA minus CA plus the second term. What's the second term? BC minus AB plus the third power AC minus BC. See, plus AB minus AB get cancels, then minus CA plus CA get cancels. AC is equal to CA, right? Plus BC minus C get cancels. What is remaining? X to the power 0 is remaining. All term get cancels means 0 is remaining, not 1. X to the power 0 is remaining. It's equal to any number to the power 0 equal to 1. It is equal to RHS of the given problem. Okay. See the next question. Prove that x to the power a plus b by x to the power b minus c to the power a minus c into x to the power b plus c by x to the power c minus a to the power b minus a, and x to the power c plus a divided by x to the power a minus b to the power c minus b is equal to 1. Okay. To simplify this one, see, first consider the LHS is equal to x to the power a plus b by x to the power b minus c to the power a minus c into x to the power b plus c divided by x to the power c minus a to the power b minus a into the power c plus a divided by x to the power a minus b to the power c minus b. Okay, first solve the term inside the brackets. You can observe terms inside the brackets are in the form a to the power m by a to the power n. What's the formula? A to the power m by a to the power n. A to the power m by a to the power n is a to the power m minus n. So here you can write it as x to the power a plus b minus what is power n, that is b minus c, whole to the power what is remaining, a minus c, into, for the second term also apply the same formula. You will get x to the power b plus c minus power of the denominator. Power of the denominator is c minus a. Okay, to the power b minus a is there, into third term x to the power c plus a minus power of the denominator, that is a minus b. Remember, here you need to use the brackets. After minus you need to use bracket because minus power of the second term, so minus of whole term. Okay, to the power b c minus b is there, plus b minus b get cancelled, so you'll get x to the power a minus into minus plus c to the power a minus c into, here c plus c minus c get cancels, so x to the power b minus into minus plus, so you'll get x to the power b plus a to the power b minus a into, here c x to the power plus ca minus a get cancels, so you'll get c minus into minus plus c plus c or b plus c to the power c minus b. Okay, now see, use the formula a to the power m to the power n is equal to a to the power mn. So what you will get, x to the power a plus c into a minus c into x to the power b plus a into b minus a into x to the power b plus c plus b into c minus b. So it is equal to x to the power, see what is a plus c into a minus b, we have the formula, right? A plus b into a minus b is equal to, what's the formula, a square minus b square, algebraic formula. Okay, so a plus c into a minus c is a square minus c square into x to the power b plus c into b minus a is b square minus a square into x to the power c plus b into c minus b, its value is c square minus b square. Now see, bases are same, right? That means you can add the powers. So x to the power a square minus c square plus the second term is b square minus a square plus c square minus b square. Okay, it's equal to x to the power c plus a square minus a square get cancels, minus c square plus c square get cancels, plus b square minus b square get cancels. all the term get cancels means what is remaining? X to the power 0 is remaining. What is any number to the power 0 value? Its value is equal to 1. This is nothing but RHS of the given problem. See the next question. A to the power x equal to b, b to the power y equal to c to the power z equal to a. Using this data, you need to show that xyz is equal to 1. Okay. So, to solve this problem, consider the given data. A to the power x equal to b, b to the power y equal to c, and c to the power z equal to a. Okay. Now see, I will consider the first equation. A to the power x is equal to b. Okay. Remember, you can consider any equations. Okay. You will get the same answer. But first I will take this one, a to the power x equal to b. Then raising powers to yz on both sides. That means both side I am taking power yz. So what you will get? A to the power x to the power yz equal to b to the power, what you will get? Yz. Okay. A to the power x equal to b is there. Okay. Both side I am taking power yz. Then see what you will get here. A to the power x yz equal to b to the power, what you will get? Yz. Okay. In the next step, see, I will write a to the power x yz equal to b to the power y value we have. What is b to the power y value? B to the power y equal to c, right? So I will write b to the power y to the power z. You can write, right? What you will get? B to the power yz only you will get. So in the next step, see, a to the power xyz is equal to b to the power y. It's in the given. What is the value? B to the power y. B to the power y is c to the power z. Since b to the power y equal to c, it is given. So a to the power x y z equal to c to the power z. What is the value of c to the power z? It also given. C to the power z, its value is equal to a, right? This implies a to the power x y z equal to a means you can write it as a to the power 1. So this implies, see, bases are equal. In the middle equal sign is there. Bases also equal. That implies powers also equal. This implies x y z value equal to 1. That is nothing but our required data, right? See, we are proved. Here see, we proved x y z value is equal to 1. Or see, I will solve by another method. Suppose I am taking b to the power y equal to c. What you have to get? X y z. Then what is missing? Y x. Then x z is missing, right? Raising powers x z on both sides. Okay, it's alternative method. Or okay, so what you will get? B to the power y to the power x z equal to what you will get? C to the power x z. Okay. In the next step, see what you will get? B to the power y x z is there. You can write it as x y z equal to, here see, c to the power x z is there. Any value we have? Yes, we have c to the power z value. So I will write it as c to the power z to the power x. Multiply, what you will get? C to the power zx. C to the power zx is nothing but xz, right? So why I am writing c to the power z? Because we have the value of c to the power z. So in the next step, see, b to the power x y z equal to, what is c to the power z? Here see, c to the power z equal to a to the power x. Okay. Then b to the power x y z equal to, what is a to the power x? Here see, a to the power x value equal to b. Okay. Since a to the power x equal to b, or here I'll write since c to the power z equal to a. Okay. Then see, b to the power x y z equal to b to the power 1. This implies, see, bases are same and middle equal sign is there. That implies powers also equal. It implies x y z equal to 1. Okay, see, again you will get the same answer. You can follow any method. Okay. See the next question. A equal to 3 to the power x, b equal to 3 to the power y, and c equal to 3 to the power z, and condition is given ab equal to c square. You need to prove that x plus y equal to 2z. So here I will take a equal to 3 to the power x, b equal to 3 to the power y, and c equal to 3 to the power z. And one more condition is given, right? So consider the given condition ab equal to c square. Substitute what is a, 3 to the power x, into b, what is b, 3 to the power y, equal to c square, that is 3z whole square. Okay, in the next step, see, 3 to the power x into 3 to the power y, a to the power m into a to the power n is a to the power m plus n. Don't write 3 to the power x into 3 to the power y is 3 to the power xy. 3 to the power x into 3 to the power y is 3 to the power x plus y by this formula, equal to what you will get here, 3 to the power z into power 2, that is 3 to the power 2z. Okay, mn, you need to multiply a to the power m to the power n is a to the power mn. Okay, now see, bases same and equal sign is there, that means powers also equal. This implies x plus y value is equal to 2z. Clear?